Hello, good morning, sir. My name is Noorada Nabila, and I'm from Group 36, and I'm going to present for my assignment 1, which is for a project called the MMU Self-Defense Course website, and I will be explaining about the background. Although crime rate in Malaysia has been steadily declining over the past few years, the number of occurrences is still high due to fear experienced by citizens. MMU has taken the initiative to set up self-defense classes for its students and outsiders to learn. Customers will be able to enroll for these classes via the system. So the objective of our project is to offer a user-friendly registration system for MMU self-defense courses to make effective digital record keeping possible for class management, billing, and enrollment, and to guarantee data security and stop unwanted access by using strong database security procedures. So for the task 2, it will be implementation of the application using SQL database. And as you can see here, this is the SQL, and we will be creating a database and tables, and then verify the tables, which is user, courses, card, and others are correctly structured. So here is the ERD design, which is it show that each box represent the tables in the database, that how it relates to each other. And for example, I will be giving each user can have a multiple enrollments, and each enrollment is tied to a payment, and each course is linked to sales data, and the admin table connects to both courses and sales for management purpose.
Good evening, sir. Today I'll be discussing Task 3 threat modeling and Task 4 PDP 2010 compliance for the MMU self-defense course system. Okay, let's start with Task 3. We utilize the STRIDE framework to identify 6 categories of potential threats like spoofing, tampering, repudiation, information disclosure, denial of service, or DOS, and elevation of privileges. Okay, for spoofing, the threat involves attackers pretending to be legitimate users like admins or students to access sensitive data. To counter this, we implemented secure login mechanisms with hashed passwords and strict credential verification. Okay, let me scroll down further. Okay. For tampering, which could involve unauthorized changes to database records, we used tools to monitor and log all modifications. These audit logs allow us to track who made the changes, what was altered, and when. Okay, repudiation occurs when the user denies actions like deleting or modifying records. To address this, we log every action performed in the system, complete with timestamps and user identifiers to ensure the accountability. Okay, moving to information disclosure, this threat involves leaking sensitive data such as student details. So we mitigated this risk through role-based access control. For example, students can only view their data while admins can access the entire database. For denial of service or DOS could disrupt the application due to the overwhelming traffic or resource exhaustion. To prevent this, we limited active connections, closed idle connections, and continuously monitor system resources. Lastly, for elevation of privileges, where attackers attempt to gain admin level access, we enforced strict role-based permissions and locked every access attempt to ensure unauthorized users cannot elevate their privileges. For the should be enough. Okay, should be enough. Okay. We also use the threat framework to evaluate threat severity based on factors like damage, reproducibility, exploitability, affected users, and discoverability. Okay, for example, spoofing, information disclosure, and elevation of privileges scored the highest because their severe impact and ease of detection using automated tools. Okay, now let's move on to Task 4. Task 4 PDP 2010 compliance. Okay, the Personal Data Protection Act, PDPA, requires that we handle personal data responsibly throughout its life cycle. In this project, we identified 3 roles: the data user, which includes admins managing enrollment, the data subject, referring to students enrolling in classes, and the data processor, which is the backend system handling storage and processing. Okay, to ensure compliance, we implemented several measures. During data collection, we obtained explicit user consent through forms and only collected necessary information. While processing data, we ensured fairness and security by encrypting data with AES 256 and enforcing role-based access controls. For data storage, we maintain regular backups, encrypted sensitive information, and enable access logging to track activities. Okay, I'll scroll down a little bit more. Okay. When sharing data, we must sensitive details and require explicit consent. For data retention, we established a clear policy to store data only as long as necessary, securely deleting it afterward. Finally, during data disposal, we use secure methods like threading and verify disposal logs to ensure compliance. Non-compliance with PDPA can result in severe penalties such as fines up to RM 300,000 ringgit or imprisonment for up to 2 years. Okay, that's all for me. I'll pass to the next person.
So for Task 5 is security measure implementation.
I will now be presenting the security features implemented on our website. alongside earlier, but we will not be focusing too much on the website structure. We'll be focusing on just the security features. A quick run through is we have our courses, schedule, instructors, student pass, checking about us. That's what our website has. So our first security feature is to prevent spoofing. We enforced a strong password policy. So you have our requirements, and let's try to register. If we do not follow the requirements, let's just say Brim123 doesn't follow requirements, it prevents the registration. And then to also prevent spoofing, we have password hashing, which contributes to preventing spoofing. Let's just try and sign up. Vim yes, okay. Registered. We have a look at our table here in the database. Once refresh, you can see our new entry has been inserted, and our passwords have been hashed using the SHA-256 algorithm, thanks to our trigger that immediately hashes the passwords before they get inserted into the database. Okay. And then after that, we also, to prevent tampering, we implemented parameterization of queries where we sanitize the code to make sure that SQL injection cannot happen. So let's just say we try to log in here. So a few things can be done to try and perform SQL injection. You can put in something like this to bypass authentication, or like this to always have a true condition. This can mess with the SQL structure, this as well. So let's just try one by one. So as you can see, despite 4 attempts to perform SQL injection, it was not possible thanks to our code sanitization.
Of the audit logging, I will be showing you here how it works. So when the users add to cart any courses, and then check the shopping cart, and then try to remove it, and then check your database on audit logs. As you can see, there's this insert cart and delete cart. So every action performed in this entry, it will send a trigger into the audit logs. Connection limitation. To prevent a denial of service DDoS attack, we configure several MySQL settings in the my.file for XAMPP. So here, some configuration setting to prevent the DDoS attack. First, we limit the maximum connection number of simultaneous client connection to 100, and then set connection timeouts, which is the idle connection are closed after 10 minutes to free up the resource. Third, enable connection throttling. Block host after 100 failed connection attempt. Prevent the abuse. Fourth, connection on hold. This determines how many connection requests can be waiting while the server is busy handling others, which is the backlog is 100.
And now we also implemented dynamic data masking. So let's just try and log in here. So this user has already signed up for Taekwondo and Karate. So for Taekwondo, these are the people in his class. Darwin is here. As you can see, his email has been masked. Karate, Laku, Darwin, Wim, all these people, their emails have been masked. Only the logged in user has their email displayed. Whereas for our admin, let's log into the admin. So we've given the admin their own page to perform their tasks. As you can see, for the admin, all entries, all emails are not masked. So there is dynamic data masking present. After that, we have role-based access control. So we've separated the users and the admin by giving the admin more privileges by like their own page, where they can perform more features, they have more function, whereas the user is limited to just registering for courses. We have enforced least privilege by implementing code to prevent basic users from accessing the admin page. So let me just demonstrate that. Let's log back into the basic user. So the basic user is logged in. So over here, if the basic user attempts to log into admin.php, let's try to access. See, as you can see, immediately their session got terminated, they got logged out, and they've been sent back to the main page. That is all for our security features. Thank you, Dr. Awan.